Naturen er ikke så skrøbelig, som medier og politikere gerne vil gøre den til. I dag snakker jeg med Patrick Moore, som er medstifter af organisationen Greenpeace. Vi skal snakke om isbjørne, CO2 og fugle, der fodrer deres unger med plastik. Velkommen indenfor. Mr. Moore, thank you for taking your time to talk with me.
Yes, I have all the time you'd like, Ricky.
Can you, for the viewers who don't know you, can you please introduce yourself?
Yes, Ricky, I had a very interesting childhood in that I was born in a very remote place with no road to it on the northwest tip of Vancouver Island in a floating village of only about 50 people, my father's logging camp. And close by was a small fishing village where my mother's family was living before she married my dad. So the two of my mother and father were both from pioneer families on the west coast of Vancouver Island, where only boats were the only way to travel. There were no airplanes when I was a small child, and certainly no cars because there was no road to this place. It was a total isolated coastal community. And so there, I was growing up in the rainforest of the northwest of Canada in a most beautiful environment, with the only industry being the fishing and forestry. And I had my own boat when I was 8 years old. And then when I was 12, I had a motor on a boat, and I built 3 small boats. When I was 13, 15, and 16, I built boats for myself, and that's how I grew up. But when I was 14, even though I returned home every summer to work in the forestry, I was sent to Vancouver, which to then for me was this huge city, to a boarding school where I lived for 4 years. And it was a good school based on the English private school system, or what they call the public school system in England, which means they are private for some reason. I excelled in science and was top of my class, and really became interested in particularly life science, the biochemistry, biology, and genetics, and plant physiology and forestry, and all these subjects about life. And when I entered university, I did a Bachelor of Science in life science and then on to a PhD in ecology. And just as I was entering my PhD in ecology in the late 1960s, the word ecology had not yet been in the popular press. No one knew that word. Environment was beginning to become prominent as the consciousness of the environment was coming into the mainstream at that time. And of course, it was the height of the Cold War and the threat of all-out nuclear war, the height of the Vietnam War, and the emerging consciousness of the environment, all happening at one time. And that is why Greenpeace was born then. Green for the environment, peace for the people. And because our first campaign was to go against US hydrogen bomb testing. We saw nuclear war as the greatest threat to both the environment and civilization. And that was a wonderful marriage of the two because, of course, all life is one, coming from the same beginning. And one of the main reasons after 15 years of campaigning and leading many campaigns and being the top spokesperson in the organization, of course, there was no internet then, so there's not a lot of legacy from this unless you go back, way back, and find old newspapers. But there I was, campaigning all those years. And it's interesting, though, that what happened along the way was the peace kind of got lost in the campaigning. When we went to save the whales and stop toxic waste and this, the environmental movement began to characterize humans as the enemies of the earth, the enemies of nature, as if we were completely separate from the rest of nature, which was all good. And so, okay, we are the only evil species on the planet. like I was not brought up in a religious fundamental family. We were quite non-religious, in fact. So I was more science oriented, and I realized that this was like original sin in hardcore religion, where people believe they are born with evil and all of this. And I never have accepted that. I know that most people are good, and unfortunately, it only takes a few evil people to wreck things once in a while and become dictators and only care for themselves. But that is not true of most people. And so I couldn't stay in an environmental group, and now most of the environmental movement reflects this position that humans are the bad guys in evolution. And I don't see it that way. I see that humans are an incredibly unique species, that we are the first species that cares about endangered species other than ourselves. No other species is concerned about endangered species, even though by far the most species that ever existed already went extinct a long time ago. Now that we are so strong in our influence on the planet, we have programs to make sure new species do not go extinct anymore as best we can. And there's no other species that cares that much about other species than we do. So that's a bit of my history. When I left Greenpeace, as I say, I wrote this book, Confessions of a Greenpeace Dropout, explaining why I had left after all those years and documenting our exploits through those years, which is a fascinating story in itself. And then, since 1986, I have been working to be a sensible environmentalist, basing my positions on science and logic, and not on misinformation, sensationalism, and fear, as the mainstream environmental movement has tended to go.
Wasn't the Greenpeace the first like environmental group like worldwide known group to like be on the news? And I'm 45. I remember I grew up in the 80s, and I remember these news stories about Greenpeace saving the whales and toxic factories, and I remember that stories, and I don't remember anyone else, any other group who was that prominent in that kind of work at that time.
Well, I think you're correct, Ricky, that we made Greenpeace the most well-known environmental organization in the world. And
Mm.
before that, there were some important organizations. The World Wildlife Fund, which is now called the Worldwide Fund for Nature, uh, but they were not campaigning organization back then, and still mostly they are uh, a different category. They are more information-based writing, and that they don't go in protests so much. Uh, there was also the Sierra Club, but this was mainly in the United States and Canada, which was founded out of the wilderness preservation movement in the United States by John Muir and at the 1900s. So it had been a major force in wilderness protection. But Greenpeace became an environmental group in the broad sense of the word, in the total and global ecosystem protection. And unfortunately, though, with many organizations, they start with noble intentions as volunteers. Pretty soon they become very successful. And becoming successful, they have to raise money to pay for their employees, etc. And this is a big problem. Uh, Greenpeace began as a volunteer organization with noble intentions to save the world from environmental problems. But soon we became very successful, and then we had employees, and then we had a payroll, and we had to work fundraising to get these monies. And then fundraising became almost more important than campaigning. And pretty soon I found that my fellow directors were just making up campaigns to raise money. And uh, today I think they have basically changed into almost like a racket, uh, which is fooling people with false claims, like plastic is poison is one that we could talk about. Because of course plastic is not poison, but they have made it so in their own campaigning and fundraising. Well, actually, we didn't own a ship in the beginning. We chartered a boat to go on the first voyage. We chartered a fishing boat to go to Alaska, a small boat, only 25 meters, and we went across the whole Pacific Ocean to Alaska to protest in stormy seas. It was quite an adventure, but we succeeded in getting the United States, then under President Nixon, to end the hydrogen bomb tests in Alaska. So this was Greenpeace's first big victory. Now, we weren't the only ones protesting, but we were definitely the tip of the spear in the campaign, because we went out in a boat to go to the test site, and this got a lot of media and people marching in the streets in our support. And then we attacked French atmospheric nuclear testing, again with a small sailboat. In that case, David McTaggart's sailboat, the Vega, was used for 2 years in a row, 72 and 73, against the French tests. And then finally in 1975, we we chartered, but this time a big boat, 150 feet or nearly 50 meters boat, which we went against the whaling fleets in the North Pacific. It was not until the European organization based out of London with David McTaggart bought the first Greenpeace boat, a research vessel that had been used in the North Sea for researching fish, was bought by Greenpeace and renamed the Rainbow Warrior. And so that was actually not until 1978. And then after that, there have been 3 Rainbow Warriors. Now, Rainbow Warrior 3, we bought the first one for $40,000 and then fixed it up for another 10 or 20. This new boat that Greenpeace has now is $32 million, the Rainbow Warrior 3. And they claim it is a sailing ship, but it has a 1,800 horsepower motor in it, a diesel motor in it. So it is not a sailing ship. It does have sails, and nautical people call this sail assist, because if the wind is blowing in the direction you want to go, then you can use the sail. But if you wake up in the morning and you want to go south and the wind is blowing north, you have to use the 1,800 horsepower motor. They never say this, though. They never talk about the fact that there is an engine in the boat, because, of course, it uses diesel fuel, which is fossil fuel, which they are opposed to. So it's all become, I would say, almost a joke. And the people who are going on this boat, it's like a summer cruise for university students. They aren't doing anything dangerous like we used to do in the days when we were campaigning against nuclear testing and stopping the whaling slaughter in the ocean. We were risking our lives in these small boats in these campaigns. And
I remember mostly the whale, the when you put yourself between the cannon and the whales in the small boats. I remember seeing that on television, on the news, with my parents at that time.
yes, that is what made us most famous worldwide, was that first campaign in 1975 to stop the Russian whalers in the Pacific Ocean. And it took us 4 years, but we eventually ended all large-scale whaling in the oceans, except for the Japanese still kill some whales in Antarctica, but it's nothing compared to 30,000 whales were being killed each year in the oceans, mostly in the Pacific.
When you're talking about animals go extinct and save them, that's how you do it to prevent them going extinct, not hunting them.
Yes, and it is true that overhunting has been a major cause of animal extinction throughout the years, but not so much today. The polar bear example in my book is a classic case. Very few people know that in 1973, due to wildlife biologists warning the Arctic countries that the polar bears were declining in population due to hunting, to get a rug for your fireplace. Lots of people were going up there It was easy to fly up then in the 70s, whereas it had been more difficult in past years. And you could hire an Inuit guide to take you to kill a polar bear or two. And this had no restrictions. It was open. And so in 1973, all of the polar nations, including Denmark, because you have a lot of polar bears on Greenland, all these countries signed a treaty to end the unrestricted hunting of polar bears. And since that time, unbeknown to most of the world population because of the false information spread by Greenpeace and other groups, the polar bear population has increased from somewhere around 8 to 10,000 to somewhere around 20 to 40,000 today, because the hunting was ended. There is no possibility that the polar bear will become extinct anytime soon, because its population is growing. And this is not being told to the public. But if people read my book, my new book, Fake Invisible Catastrophes and Threats of Doom, they will see very clearly in Chapter 4 on polar bears that the polar bears are not going extinct. And this is documented very, very thoroughly by experts in the field. And here's a case where people have to rely on the propaganda from the people who have the most financial and political interest in their stories. And this is the crux of the book. And the book does two things in this way. First, it shows that nearly all the scare stories are about things which the public cannot observe and verify for themselves. And it shows that the general public is the one who is being fooled here. The average person in the street, the normal person, is listening to these scare stories. And so I'm connecting the science with the public in this way.
We all seen that footage of that starving polar bears who kind of started all that discussion about the polar bears and sea ice and all that.
That's right. But what most people don't realize is that the main cause of death for polar bears is starving to death. That's because they have no predators. They are a top predator. So there's nothing that kills polar bears and eats them. So when they get really old, I mean, there are no nursing homes for old polar bears. They have to die in the wild naturally. And so it's easy to find a starving polar bear in a population of 30,000, because some are dying every day, no doubt. And they are dying because they have reached the end of their life, like people do too. Some people forget that every living thing is going to die and be replaced, hopefully be replaced by new living things. And one of my favorite concepts, which very few people stop to think, is that every living thing, all the billions of living insects and fish and trees and people and birds and forests on this earth, every one, represents a continuous, successful reproduction since the beginning of life. If the chain is broken, the next one doesn't come. So people need to think of that. We are on a time front of 4 billion or 3.5 billion years since life first existed. And life has continually branched like a tree, branching and branching and branching ever since then. And all of us go back to that beginning, or we wouldn't be here. And this is even though there have been 5 major extinctions through either asteroids striking the Earth or volcanoes darkening the skies, both by the same mechanism of sending vast amounts of material into the stratosphere, where it blocks out the sun and prevents photosynthesis in the plants, which destroys the food chain for all of life. And these extinctions have occurred 5 times in just the last 500 million years. Before that, everything was in the ocean and microscopic, so we don't know really about the extinctions back then. But in the last 500 million years, there has been on average one mass extinction every 100 million years. The last one being 65 million years ago when the dinosaurs went extinct, that one being from an asteroid contact. But we don't know what happened with the previous ones. They're too far back to have a perfect record. And so it could have been an asteroid and it could have been massive volcano activity, but we don't know. But still, even though over 90% of all the species that ever lived are already extinct, biodiversity is higher in this era, in this last few million years, than it ever has been in the history of life. National Geographic, February 1999, has a wonderful graph showing this to be true. And whereas National Geographic has gone off on some terrible informations telling people that the polar bears are dying from climate change, etc., this one graph is worth seeing, which is in my book, reproduced in my book, to show people that biodiversity has continued to rise ever since life began.
I reached out to you because you have some interesting papers regarding climate change and waste, and you published a number of papers of these issues some years ago, and now you write a book. Why do you feel the need to have a book?
Well, this is actually the third book I've written. My first book was about forests and trees and how important they are to civilization and to the environment. There's sort of two types of people about trees. Some people who think it's really okay to cut them down and make things with them, and other people who say, no, don't cut the trees. So I tried to give a balanced view of how trees are important on so many levels, not just using them for wood and paper and all the other things we do, which is good because trees are the most renewable and abundant resource in the whole world, and also provide in forests the habitat for the species, and they clean the air and water, and they are a beautiful biodiversity and so many things. So the book was about the many aspects of trees and forests, both for using and for enjoying, and for the state of the environment. And then the second book I wrote was titled, in 2010, was titled Confessions of a Greenpeace Dropout, The Making of a Sensible Environmentalist. And this was my main transition in life. I've had a few, but this was certainly the most important one, where I spent 15 years a co-founder of Greenpeace on many campaigns, leading campaigns. I was in the top committee. Last 6 years I was a director of Greenpeace International. But I had to leave in the end because Greenpeace went one way and I had to go another. And I saw that Greenpeace had turned basically into a fundraising machine, inventing new campaigns that were not really based on truth. And that has continued to this day. Whereas I wanted to go ahead with my science. None of my fellow Greenpeace directors had any formal science education, and I believe that is true today as well. And now they are mainly backroom with all of the globalists plotting to end the use of fossil fuels and to say that plastics are poison and all these fake things that they are up to. So the second half of my book, Confessions of a Greenpeace Dropout, the first half is my history in Greenpeace, 15 years of campaigning, which is an interesting story in itself. And then the last half is all the environmental issues that are brought up today and my critique of these. So this book, I'd say, I mean, I don't know for sure, but I think it's going to become the most important book I've written, because this is aimed at the general public, not just at other scientists. Its purpose is to explain that nearly all the scare stories that there are today, from climate change to polar bears to coral reefs going extinct and all these things, are actually about things that are either invisible, like carbon dioxide and radiation from nuclear power, or they are so remote, like polar bears and coral reefs, that the average person cannot observe and verify for themselves whether these stories are true or not. the scare stories about the end of the world and all this. And so that is my thesis. And of course, things in the future are also invisible and remote in that they haven't happened yet and aren't happening now. So all of those categories, I think virtually every single scare story, alarmist narrative, as they like to call them, narratives. Narrative should be confined to fiction, not to science. And I believe they are all based on things that the public is therefore required to listen to the media, the activists, the politicians, and the scientists making fortune from government money on grants to study these catastrophes, as they call them, emergencies. We have to rely on them to tell us the truth, because we can't go to the Arctic Circle and count all the polar bears. We can't go and see if the coral reef, the Great Barrier Reef, which is bigger than Texas, we can't see if it is healthy or dying. And they are telling us it's dying, and they are lying to us. So in almost all of these cases, they are either wildly exaggerating or lying. And this is what my book is about, and it has 16 chapters. It has 12 chapters, all of which are about a particular scare story that I believe is not really true. And we could go through them, or you could pick, if you know the chapters, you could pick whichever one to discuss with me. But I'm very certain that people who read the book after I've published it now and had so many good reviews, especially from people who are saying it's understandable to non-scientists. That's why I made the cover a kind of cartoon, because I don't want to make it look like it's a science book that only people who understand big science words could read. It is a book that anyone 12 years and old, well, say 14 years old, can read it if they have any understanding of the language and the science. They don't need to know any big words to understand this book.
In your book, you're also talking about you're talking about not to demonize carbon dioxide as much as we do. What do you mean by that?
What I mean by that, Ricky, is that we are being told that carbon dioxide is pollution. We're being told that it is toxic, basically, and that it will kill life on Earth if it's allowed to continue being put into the environment. When, in fact, carbon dioxide is the most important food for all of life on Earth. We are carbon-based life. All the species, in the ocean, on the land, and in the air, every species is based with carbon. That carbon is coming entirely from carbon dioxide in the atmosphere and in the oceans and lakes. That is where life gets its carbon. And carbon dioxide is lower now in this era of the last 5 million years than it has been in all the history of life on Earth. Carbon dioxide has been constantly depleted over these years. And this is all in my book with graphs, etc. It can't be explained in 5 minutes. But it is true that the increase in carbon dioxide that human beings are responsible for in the last 50 to 100 years, mostly in the last 50 years, is a gift to life, is the salvation of life. Because carbon dioxide was trending downwards over the last 150 million years to such an extent that would eventually reach the level at which plants can no longer survive, which is 150 parts per million. During the last major glaciation, as cold seas soaked more CO2 from the atmosphere, dissolved in the sea, CO2 in the atmosphere shrank to 180 parts per million. This is well documented from the Antarctic ice cores. 180 parts per million is only 30 parts per million above the death of plants. And indeed, many plants did die during this period. As the Earth warmed coming out of the last major glaciation, which was only one of about 45 major glaciations in the Pleistocene Ice Age, which we have been in for 2.6 million years now. It was not the end of the Ice Age when the last glaciation melted. It was only the end of one of 45 major glaciations within the Ice Age, the Pleistocene. And today we have been 10,000 years in an interglacial period, which is warmer than when we were in the Pleistocene glacial period. But it is still colder now in this interglacial period, with massive ice caps on both North and South poles, than it has been for 250 million years. If you look at your history of graphs of the temperature of the Earth estimation going back 250, 500 million years, you will see that the Karoo Ice Age ended 250 million years ago. It lasted for 100 million years. This is well documented. This is the next ice age after that one, and it is only 2.5 million years old, 1% of the age of the Karoo Ice Age. We have no idea when this ice age will end. We should be very careful about thinking it is too warm, when in fact it is colder than most of life has been. So our emissions of carbon dioxide have begun, very little, but begun to reverse the decline in CO2 in the global atmosphere. This will prevent the extinction of all life in millions of years to come. And so we are a blessing in that sense. We are the savior of life, not its destroyer. And why we did this, it was inadvertent. We didn't do it because we were trying to do something good. We did it because we needed energy, and we discovered fossil fuels to provide that energy, which is more than 80% of all the world's energy today. But by using that energy, we are returning carbon dioxide to the atmosphere and the oceans that was sucked out of them in previous millennia. The fossil fuels are made of plants. Plants on land make coal, the forests made the coal. Plants in the sea, phytoplankton, made the oil and gas. These plants made those fossil fuels through photosynthesis. So all the fossil fuels were made with solar energy from the sun in plants. While they were growing, those plants absorbed carbon dioxide from the atmosphere and the oceans, and much of it ended up in sediments. Sediments on the land in the form of coal, and sediments in the sea in the form of huge deposits of marine sediment, including the shells of the species that live in the sea. Many species in the sea learn to make shells to protect themselves, like oysters and clams and mussels, the shellfish, and crabs and shrimp, and many microscopic species such as the coccolithophores and the foraminifera, all figured out how to take carbon dioxide in the ocean and combine it with calcium in the ocean to make calcium carbonate shells. This is what limestone is made with. All of the limestone, chalk, and marble in the Earth's crust, virtually all of it, is of life origin, made by marine species building protective armor plating for themselves to protect their soft bodies inside. This is where most of the carbon dioxide has gone. And by burning fossil fuels and making cement, which uses limestone and puts CO2 in the atmosphere, 5% of all our CO2 emissions are from cement manufacturing. By doing these two things, we are restoring a balance to the global carbon cycle. And this is the truth, not the lie that CO2 is toxic and a poison. No. It is the very substance of life. And in that sense, it should be almost worshipped rather than despised like it is today.
Carbon dioxide is actually just plant food, nothing more, nothing less. Yeah.
Precisely.
You talk about that the decline in carbon dioxide through the Earth's history been declining, and in your book you talk about that marine life has learned how to protect themselves from with calcium carbonate. How fast is this process? Is it fast? Let's say we didn't find fossil fuels and it continued to decline with each ice age or a cold period. How long time you think it will last before we pass that threshold for 150 parts per million?
Well, Ricky, if you just draw a line extrapolating the trend for the last 150 million years, it's somewhere between 2 and 5 million years from now, which seems like a lot, but life is 3.5 billion years old. So 2 to 5 million years is a blink of an eye in the history of life. And so if we hadn't come in some time in the future even, but now we're doing it now, we are restoring this balance, and we have gone from 280 parts per million up to 417 at last count, just the other day. And still 417 parts per million is nowhere near even the average level of carbon dioxide over the past millions of years. CO2 has been at 1,000, 2,000, 3,000, 5,000, and even 10,000 parts per million. And life was thriving in these times, very rich indeed, because that is the food for plants. And I tell a funny little story to give people an understanding of this. I used to laugh at people who told me that their plants liked it when they talked to them, and that they grew better and were more healthy if they spoke nicely to them, sit in a chair beside their plant and talk to them. Well, of course, plants don't have hearing. They don't have ears to hear what people are saying. So I would say, oh, that's kind of silly. Then I realized that when you are talking to your plants up close, you are breathing 40,000 parts per million of carbon dioxide onto the plant, 100 times as much as is in the air around them. So, of course, when you talk to your plants, especially if you spend a little time there, they will enjoy that because they will be getting a super saturated fertilizer from your breath, because we breathe oxygen, whereas plants breathe carbon dioxide and breathe oxygen out. We breathe oxygen in and breathe carbon dioxide out, which is their food. So they give us our food and we give us their food. It is a circle of life, and everybody should know that.
Do you think that people forgot about this? Because I assume everybody learned that in high school or some part of their school time. Why is people so, let's say, unknowledged, or did they just forget it?
Well, I think it's partly because fear and authority, people like Al Gore, and I don't know why they think Greta Thunberg is an authority, but they do, because she is speaking to the United Nations and all of this. I think people are capable of compartmentalizing things in their mind, even though they probably know that CO2 is part of a cycle of life and that plants are using it. They somehow can easily forget this and go with the emergency narrative, the catastrophe narrative. I'm not a psychiatrist or a psychologist, so I don't know how this works. All I know is I don't allow that to happen to myself. When I hear somebody telling me the world is coming to an end or that great catastrophe will befall us soon, always in the future, of course, I question it, because I am a scientist and it is the absolute, scientists must be skeptical. It is the rule of science. The first rule of science is to always question when somebody tells you something, especially if it's a prediction about the future. If somebody tells you about something they believe is happening now, in other words, not in the future, but today, then it's very important to check that for yourself. That's why I've written this book, because people can't check for themselves things that are invisible. You can't point to the carbon dioxide and say, look what bad thing that carbon dioxide is doing over there. You can't point to radiation from a nuclear reactor and say, oh my goodness, we will all die from this radiation, when in fact the sun is actually one of the main sources of deadly radiation there is on this earth. Ultraviolet radiation causes cancer if you sit in it too long, and everybody knows this. But we don't ask for the sun to be blocked out or to be banned, because then life would end. And so, in the same way that the sun is a giant nuclear reactor giving off radiation, some of which is very dangerous, nuclear reactors are also a nuclear reaction which has some radiation associated. But if the proper measures are taken, which is the case in everywhere in the world, except for this stupid design Chernobyl style reactor, which blew up. Chernobyl is the only nuclear reactor that has caused death to people. 3 Mile Island caused no harm. Fukushima, no one died from radiation, and no one will, because no one received a dose large enough. All the nuclear experts agree with that, but they still make it like it was the worst catastrophe in the history of the world. It was not. It was just a very expensive accident, industrial accident, which has cost a lot of money to Japan. And the fact is they could have easily avoided that accident if they had listened to scientists from other countries. But the Japanese are quite insular in their society, and they didn't listen. Now they know, and they won't do that again, one can hope. But the truth is that the nuclear reactors are one of the very safest technologies we have ever invented. And in my book, I give the numbers. Nuclear reactors have caused the death of less than 60 people, all in Chernobyl. Traffic accidents in the roadway accidents, are 1.2 million people per year die in roadway accidents. So you are 1 million times less likely to be harmed by a nuclear reactor than you are if you simply walk or bicycle or drive on the road, which almost everybody does every day. And even though I know these odds are so amazingly high compared to nuclear reactors, I still will not give up my car or my bicycle, because we all know how important those are to our mobility and our ability to move from one place to another with relative ease. And so we're not going to give that up, even though the risk to ourselves is so much greater than it is from nuclear energy. And we talked about CO2. There is no risk to you from CO2. It's all positive. And yet they've got us thinking that it's going to cause the end of the world.
Yeah, there's a 400 nuclear power plants around the world, and there only been like that 3 accidents you talk about, and only one really was a fatal accident. And that type of reactor, they don't use it anymore, unless only in Russia, I believe.
Yes, and the Chernobyl class reactors in Russia have been retrofitted extensively to make sure that that accident can't happen again. And most people don't even know that that accident at Chernobyl did not happen during normal operating conditions. It happened because a group of engineers from Nuclear Central in Moscow came to the reactor to do an experiment. And they told the reactor operators to shut the safety systems down so that the safety systems would not interfere with their experiment. And that's why the reactor went critical. That was actually a slow nuclear reaction, a slow bomb, which happened there and blew the top off and spread radiation all around the area. That's not what happened at 3 Mile Island or even at Fukushima. Those were meltdowns of the reactor core caused by lack of cooling after the reactor was shut down in an emergency. So the Chernobyl accident was not only unique in that it killed people, it was unique in the type of accident it was. Other reactor designs cannot have that accident.
No. And in Europe, you have especially in France, they use a lot of nuclear power, and they actually kind of supply whole of Europe now.
Yes, and they should start building. They should start building new reactors in France because they have the political climate to do it, hopefully. But even France has an anti-nuclear movement now, and if France, another really important statistic is the CO2 emissions from France and Germany compared. France has only slightly more than half the per capita CO2 emissions of Germany. That's because of its nuclear reactors not emitting CO2, whereas Germany has a lot of fossil fuels in its in its energy production. And now Germany this year and next year will shut down its remaining 8 nuclear reactors as decreed by Chancellor Merkel after the Fukushima accident. We will see if they do that. If they do, their CO2 emissions will rise even further because even though they have a lot of wind and solar, they require backup for that wind and solar when the wind isn't blowing and the sun isn't shining. And right now, the nuclear is a big part of that backup. And if they take that away, they will go even higher in CO2 emissions when they are pretending that they are so progressive in the move to reduce CO2 emissions. Germany is not progressive in this way. And a fact that almost no one wishes to know outside the United States and even in the United States, because so many people in the United States are anti-American, which is rather weird, but that's what apparently has happened. Many people do not know that the United States is the only industrial country that has actually reduced its CO2 emissions dramatically in the past 15 to 20 years, largely because they are switching from coal to natural gas for much of their electricity production, not because of climate change. They're doing it because the gas which they are now fracking is cheaper than coal to make electricity. So they're moving to a cleaner fuel because of economics, not so much, or not even at all, because of climate. Although now, with President Biden elected, you will see a lot of rhetoric around the issue of CO2 and climate change and switching off fossil fuels. But the truth is the United States was already the only major country reducing its CO2 emissions without any climate change policy in that regard. Whereas China and India are both increasing their CO2 emissions, where now I believe China is using as much coal as all the rest of the world combined for their electricity production today, and it will only continue into the future, and we cannot believe them for 5 seconds that they are actually going to be net zero in 2060. No. It's pure propaganda, like so much else that is coming out from there.
The same is happening in Denmark. They use a lot of money in wind farms and not so much solar because we are so high latitude, but we have a lot of windmills. But we have just had almost 3 days with no wind. That means we get all our backup power from Norway or Germany. But when the wind is calm in Denmark, usually it's also calm in Germany. So they also need backup from, and most of that backup is from France, nuclear power plants, and some of it also from coal-fired power plants in Germany. But they also seem to want to close them in the future. But the grid, the backup grid is becoming more and more fragile. This winter they have seen very close to blackout somewhere in Germany because of lack of backup power, backup energy, because of that policy.
That's right, Ricky. And the good thing about this is it will become self-correcting. You see also blackouts now in Australia, California, and just recently in Texas. And this is all because of excessive reliance on so-called renewable energy, which is not reliable and is very expensive. And soon, as we say colloquially, the gig will be up, the jig will be up. And this is going to come as a shock when people realize that they have gone down a trillions-dollar pathway that is not acceptable for the future, that is not viable. It is all a fad or fashionable, as you would say. There's no place for this. If the subsidies and tax credits and mandates were taken away from wind and solar, they would not exist. And my slogan about them is they will rust in place as opposed to rest in peace. And I believe this is true. In the end, they will be abandoned because they only have a short lifetime to begin with compared to nuclear plants, for example. But they also will prove to be one of the biggest mistakes in technology that the human species has ever made.
It's a windmills. It's not a new thing. A lot of farmers and other countryside production have used them for many years, but in large scale, for supplying a whole country, they're not really sufficient enough and extremely expensive.
Yes, they are, and they, I'm not against wind and solar for off-grid applications. I actually have a home in southern Baja, Mexico, where the sun shines a lot, and we have solar there for 20 years. But we have batteries too because there is no grid there. We're off-grid, so it's expensive. But the only other alternative is a noisy generator, gasoline or diesel generator, and in that case, solar is desirable if you can afford it. But the average person in Africa can't afford this. And the poorer people even in Europe and North America can't afford this. So we have to be realistic about this situation, that the wind and solar is not here to stay. It will be abandoned once the subsidies and tax credits and all of this are taken away from it, because these are false propping it up. They said at the beginning that it was just to get it started, but now they find out it will need these subsidies forever. And also they will need this backup power forever. Where do you get the backup power? Because wind and solar cannot back themselves because they are inherently unreliable and intermittent and unpredictable in their delivery of electricity. It was a stupid decision in the first place, and it will always be remembered as such in the end.
And now a lot of the windmills is becoming so old, so they have to be disposed. And now they have the big problem about like what to do with them, because you cannot really recycle them, especially the huge wings of plastic composite. You cannot really do anything with them because they are too big, and so usually they just place them in some big landfills somewhere and to decompose.
Well, they're not going to decompose very quickly in landfills, I can assure you of that. But I don't know what the problem is for using them in incineration in your waste-to-energy plants in Europe. Maybe it's because the glass fiber is too much of the content, but one would think that could be taken care of. The glass fiber would turn to dust almost and can be removed from the bottom of the burner. And I know from my book, as you can see there, I've studied waste to energy quite thoroughly, which is being used very, very successfully in Western Europe especially, and in Japan, and even China now has adopted this as a major way of producing some energy from the waste which is not suitable for recycling, combustible waste. And these blades are certainly combustible. They are made with epoxy, which is hydrocarbon, and glass. I don't understand why the Europeans countries are not slicing this up into smaller pieces and putting it in their waste to energy plants. I'd really like an answer to that. but I don't see an answer anywhere on the internet. So I'm waiting to hear what the answer is.
Actually, in Denmark, we have a quite successful waste program. We sort everything, our waste like glass and metal, in special containers and recycle them. Whatever can be recycled, and the rest is going to that waste power plant. But now the United European Union, is require us to recycle even more. So they have to take out plastic, they have to take out wood from the waste. Most of things that burn really well, you cannot burn them anymore. And to recycle plastic, it has to be clean. You have to sort it like clean plastic for the not clean, and it's a time-consuming process to do that. So now they export the waste to Germany, who actually has the same problem. So now they export it to Southeast Asia instead, where it just lie around in landfills and actually end up in rivers, and because of course they cannot handle it either.
Yes, well, this is what you get when you allow governments in to make decisions that should be made by markets.
Yes.
I mean, are we all going to be communists soon? This is the question. It would appear as though that's the direction things are moving. I'm not sure whether it's because the cradle-to-grave society has become so that individuals are happy not to have to make their own decisions about things or something. They would rather be controlled by high tech and government and propaganda, etc. I don't know. Where is the individual freedom gone in especially Western Europe and North America, where the reason for such success has been free enterprise markets. I don't like the word capitalism because it sounds too much like only big business. But market-based economy is the way to go. Government should be there to make regulations that are based on real facts, real issues. Whereas if you say you can't burn the wood from construction waste, what do you do with it? I mean, it's full of nails. It's in small pieces. If you take a house down, for example, or a building made of wood, that's completely stupid to say you can't burn it to make energy. And and the same with plastic. We do the same recycling here as you have described, and our garbage, our waste, is almost all thin plastic and different burnable things which are not recyclable, dirty paper, dirty plastic, etc. And it's all going to landfills in North America. The United States does have some waste to energy plants in areas that are more highly populated, like New York and big cities. But still, more than 50% of the municipal waste, or garbage as we call it, from society is going to landfills in North America. And there's an excellent graph in my book showing the difference between Western and Eastern Europe in this regard, that Western Europe is far ahead of Eastern Europe in recycling and in waste to energy, whereas Eastern Europe still has a lot of landfill. Maybe they will catch up eventually. That would be good. But the logical thing to do is to reuse everything you can in the waste stream for the best use there is for it. And the best use for much combustible waste is for burning, for making electricity and heat, which I understand in Europe provides at least 5% of all the electricity in the country, or 3 or 5%, I forget which. But it's a significant amount. It actually matters. It's not like 0.5%. It's serious percentage of the electricity in Western Europe and Europe in general is from waste to energy.
In Denmark it's mostly heat, not a little bit of electricity, but mostly it's heat, heating water through pipes.
Yes, well, it works just as well for heat as it does for electricity. and there's no reason not to use it if it doesn't recycle properly.
No,
Uh,
but the thing is, now when we have so less waste because of the the limits that we can burn, we have to sort it. That means that the waste that's left, there's not much energy in that, so they have to import wood pellets to use to burn to get heat enough, because they need more waste, and they start to import waste from East Europe just to have enough to burn. So it's kind of silly, like you export all your waste to Germany, who export it to Southeast Asia, and then we import waste and wood pellets from outside to get enough heat out of it.
yes, it's silly, and that's what happens when you allow government to make all the decisions about life. And this is classic socialist communist thinking. You know, you make 5-year plans that, and it's also, the government is always making rules which benefit the wealthiest people, even though they pretend that what they're doing is going to be good for everybody. But if you look at even the United States now, the big tech monopolies in the United States actually have virtual control of the government now. And then government has control of all the people now. So it's backwards compared to what democracy is intended to be, which is where the people are the basis of power. And that is fast disappearing. I just read this morning, for example, that President Biden has stated clearly that he will not speak against China's policies in Hong Kong or with the Uyghurs, with the concentration camps, because he says that different societies have different norms, which means he thinks it's normal for China to have concentration camps and to destroy the independence of Hong Kong, or semi-independence of Hong Kong.
Talking about waste, in your book you say that we often hear about plastic in the ocean. We have big islands of plastic floating around the oceans, but you say actually, first of all, this island of plastic is not true, but you also claim that the plastic in the ocean is not that bad as the media tell us. Why do you say that?
Well, of course, the propaganda is that the Pacific garbage patch, or the Great Pacific Garbage Patch, is twice the size of Texas and 3 times the size of France. And this is on CNN and all these fake news media, whereas it does not actually exist. It is not even as big as a small island. It is nothing. It is fake. 100% fake, and I prove this in the book with satellite photography. I mean, it's there for anyone to see. And when people go out looking for it, they do not find it because it is not there. The main problem with plastic waste in the sea is discarded fishing nets and fishing gear, especially the nets which are meant to catch fish. So if they throw away an old net in the ocean, it will catch fish for no reason. So an international effort should be made to make fishermen, maybe pay them something for their damaged nets so that they are discarded on the land properly, or burned in waste to energy plants for energy, which they would be perfectly good for. This should be done. But the truth of the matter is, plastic is actually beneficial in the sea for a number of reasons. The 2 most important ones are that plastic in the sea is no different than wood in the sea. There's a lot of wood in the sea. It comes down the rivers in floods and torrents and goes to the sea and breaks up on the beach into small pieces. Some of it remains as big pieces and floats around in the ocean, providing habitat for hundreds of different species to live on it, to lay their eggs on it, to attach themselves to it like barnacles. Plastic is no different in this way. So plastic provides habitat in the ocean. Now, they say, oh, that's no good because plastic is toxic. Plastic is not toxic. If plastic was toxic, would we wrap and package most of our food in it? We we put plastic wrap on all our meat. We put plastic packaging around much of our food in supermarkets. The reason we do that is because it is not toxic. It is sterile. It is non-toxic and not so biodegradable that it would break down before you get your food. So it is a very important substance. Nature produced the first plastic called cellulose more than 3 billion years ago. Cellulose is polyglucose, as in the same we call polyethylene and polystyrene and polyvinyl chloride. Cellulose is a fiber made with sugar called glucose. So people don't know this, but it's true. Plastic has been around since the beginning of life almost. And now we can make some synthetic ones, which have an incredible number of important uses. The other positive use for plastic is the exact opposite of what Greenpeace, the Smithsonian Institute, and Sir Richard Attenborough are telling us, that seabirds are feeding plastic to their chicks, mistaking it for food. No, they are not mistaking it for food. They are giving it to their chicks as a digestive aid in the gizzard of the bird. All birds have gizzards, which are muscular stomachs, a second stomach to the one they have, which is like ours, where they grind their food, because birds do not have teeth. Therefore, they cannot chew their food like mammals do. So, birds swallow their food mostly whole, and that food goes to their gizzard, where on land, birds feed pebbles, rocks, to their chicks, and then have to swallow rocks the rest of their life to provide the grinding action in their gizzard to digest their food. Over the last 60 years, plastic in the sea has become one of the most important hard objects for birds to feed their chicks and to use for the rest of their lives themselves. Because in the sea there are no pebbles. In the sea there are something like pebbles called pumice, or lava from undersea volcanoes, which floats because it is full of pores. It's like styrofoam. And it floats, so they can use that. But there are not always undersea volcanoes near a bird island. So that's sometimes not available. Then they will go to using small bits of hard wood and small nuts that have floated from land onto the sea. And they use that. Today, they also use bits of hard plastic. And this is actually a benefit to their survival. And if you look in my book at the graph of the Laysan albatross population, it has exploded ever since feather hunting was banned back in the early 1900s. Many seabird colonies were decimated by hunters coming to kill the birds only to take their feathers for ladies' hats and such. And this was ended. And now most of the seabirds are in very healthy populations, and they are finding these bits of plastic in the sea and using them to help their young birds in the nest to digest their food. This is all in my book, and in the final analysis, plastic is a very large net positive introduction to the marine biology.
This chapter actually surprised me, because if I take some candy in the woods, I have to take the paper home, because don't want to go around and throw plastic all around you. So this idea of plastic being beneficial in the sea, it's kind of like, it's counterintuitive, but it makes sense, so to speak.
Yes, well, Ricky, it's not beneficial in the forest, but the main point here, that plastic wrapper, if you threw it in the forest, it's not going to harm anything. Something might even come and live inside the package if it makes protection for them. But the truth is, we must distinguish between litter and pollution. Pollution causes things to die, causes like toxic pollution. We have to distinguish that. Plastic is not toxic. It is, if you see a bunch of plastic beside the road along with beer bottles and whatever people throw out of their cars, those things are not toxic. They are just litter. They are not nice to look at. We like the countryside to be tidy and clean. That's a good thing. It's just our aesthetic. It's got nothing to do with poison, though. And so we must make that distinction very clearly. Is this litter or is it poison? And where it's poison, it should definitely be stopped. Where it's litter, clean it up if you want to, because that makes it look nicer to our eyes. But it is an aesthetic issue, not a biological issue.
But how about plastic bags, like plastic waste in the ocean? It will eventually decompose, and there's a lot of talk about microplastic going into the ecosystem, and at this point we don't know really if it does harm or not. Is it something that concerns you?
No. No. As a matter of fact, this is also greatly exaggerated for one thing, because even microplastic breaks down eventually into basic components of mineral, of the elements they are made of, which is mostly hydrogen and carbon. So there's nothing wrong with hydrogen and carbon being in the ocean. But the main point is, with plastic, two things. First, when we ingest a microplastic into our stomach, we don't put it in our blood. We pass it out through the back end of us, with like anything that is not digestible. If it's not digestible, it cannot be digested. Therefore, it comes out our other end. You see, nature, the second point, nature was very smart to make, like, most animals are tubes with food going in one end and waste coming out the bottom, right? Nature made the in hole smaller than the out hole for a good reason. If you look at the medical journals, look for bowel obstructions. In other words, you swallow something and it's too big to go out the other end. There is no such subject, because anything you can swallow will go out the other end if it needs to, if that's where it should go, because it's not digestible, like plastic. So you don't have any examples of plastic causing bowel obstruction, and you don't have any example of plastic causing poisoning in people. None. Zero. Right? There are chemicals which can cause poison in you. For example, one of the most important essential nutrients is table salt, sodium chloride, which the sea is full of. Right? It's the most common salt in the ocean. But if you were to eat 4 to 5 tablespoons of salt at the same time, you would die. Because salt is toxic at high concentrations like that, which isn't really that much if you think about it. It's not even half a cup. But you just pour that down your throat and see what happens to you. So we need to get clear understanding of toxic, because toxicity is related to the amount of something. But with plastic, no amount of plastic is toxic, because it just simply isn't toxic. Like salt, your blood absorbs it because your body is designed to absorb salt because it's an essential nutrient. Whereas plastic is not an essential nutrient. Your body cannot absorb it because it cannot break it down. So this idea that, they give you the impression that the fish's liver has this big block of microplastics in it. No, it is not true. That's not what is happening. And they also make out that it's toxic, which is also not true. So if a marine organism ingests a piece of plastic, it poops it out because it cannot digest it and doesn't want it. But mostly they avoid eating plastic because they know it's not food. Just like the albatross know it's not food, and yet you have all these big environmental and institutes and famous people like Attenborough saying that the birds are mistaking plastic for food, when in fact they're not making a mistake at all. They're not stupid. They're feeding it to their chicks because it aids in the digestion of their food, which is a good thing to do.
Talking about the ocean, are they becoming acidic?
No. It is actually impossible to make the oceans acidic. They are using the word acidic when they are meaning less alkaline. Alkaline is the opposite of acidic. The pH scale goes from 0 to 14, where 0 to 7 is acid, and 7 to 14 is alkaline or basic. Those two words mean exactly the same thing. I prefer to use alkaline and acidic. And it is actually impossible to make the seas acidic no matter what you put in it. There is so much basic minerals like magnesium and calcium and sodium in the sea that it could never be made acidic. Rainwater is acidic, and lakes and rivers are generally slightly acidic, and life is living in them just fine, but not so much as in the sea, because the sea has more nutrients in it and is just where life began. It began in the sea, not in the lakes. It migrated to the lakes in the same way that it migrated to the land eventually, but it began in the sea, in that environment. Now, the most interesting fact is that carbon dioxide is one of the main gases which is dissolved in the sea. And carbon dioxide is acidic. It produces carbonic acid if you put it in fresh water, for example. So fizzy water which has had carbon dioxide put into it on purpose, like in beer makes carbon dioxide too. The fizz in water and beer is carbon dioxide, and in champagne. That makes those drinks slightly more acidic than they would be if they didn't have that fizz in them. In the ocean, carbon dioxide is the only reason, not only for the food for the plants in the ocean, but for the pH of the ocean. If it were not for carbon dioxide dissolved in the sea, the pH of the sea would be 11.3. The same as Drano, the cleaner you use to clean your drains in your house where the water goes out, which is very, very alkaline. It can burn you, right? It can burn you. Whereas the CO2 in the oceans modifies the alkalinity to make it lower into 7.8 to 8.4 in most areas of open ocean. So there's a variation in the alkalinity of the oceans all over the world. But to call it ocean acidification is propaganda in itself, just using the word acidification, because people think of acids as being something that burns you, something that's toxic, etc., whereas they don't think of alkaline as toxic, even though highly alkaline solutions like Drano, I don't know what your word for this is in Danish, but it's the very strong chemical that you pour in your sink to clean the fat and other materials out to make your water flow properly. That is highly poisonous as well. It's just that we're triggered to think of the word acid as a bad word, and the word alkaline is not thought of as a bad word. The oceans are alkaline, they always will be, and carbon dioxide dissolved in the oceans is the reason why they can support life, not only because of the fact that carbon dioxide is the food for the life in the oceans, but because it reduces its alkalinity to a level which life can live in, whereas it could not live in the oceans just because of the alkalinity, never mind the food value, if there was no CO2. So CO2 provides these two extremely important factors for life in the sea, which is where it began.
First time I heard about this world oceans becoming acidic, my first thought was, how do you measure that? How do you measure a world ocean pH? Impossible mission to do that in a regular basis.
That's because it's a fairy tale, not a scientific fact. So it's easy to measure things in a fairy tale. They cannot measure the pH of the oceans everywhere. The pH of the oceans varies from place to place way more than they say it's going to change from CO2 going in it. There's no way you can do that. It's the same with the temperature of the oceans. They say the oceans are heating up. Well, it's not as if they have a thermometer at 6,000 meters in the oceans. This is all theoretical. It's all based on either insufficient data or no data with a computer model or whatever. They make stuff up. That's one of their hallmarks, is they're good at inventing things that don't actually exist. And they're saying, we couldn't, actually the concept of pH was not invented until the early 1900s. The concept of it. And a tool to measure it was not invented until the 1920s into the 1930s. We didn't even have a tool that could measure pH until then. It's actually not an easy thing. A continuous monitoring of pH is virtually impossible. It has to be done one at a time. And so we do not know in any way that CO2 has changed the pH of the oceans. There's no way to know that. The theory would be that it hasn't, because there is actually no evidence that CO2 is being absorbed at a higher rate by the oceans due to the higher amount in the atmosphere. We don't know that for sure. We do know that higher CO2 is resulting in much higher vegetation growth all around the world, especially where it is drier, because CO2 increase also makes plants more efficient with water. So places where only grasslands can live now because it's too dry for trees are coming out onto those areas due to the higher CO2 which we have caused in the atmosphere.
You have been in this first as in an environmental group and now in a science community. This slide towards political-based science, as we've seen in a last decade. When did you see this start out?
Well, it started when the environmental movement became successful, I would say. There's an old slogan, fear success. It brings with it a lot of problems.
Yeah.
Like for us in Greenpeace, a payroll to meet every month. And many organizations go through this evolution, and starting out with good intentions end up being part of the problem. And the same is true with much of the environmental movement today. They have so much power and they use it mercilessly, and they use it irresponsibly from a science point of view. I can't really say it any other way.
It seems like last maybe 10 years it has increased more, like people like you who talk against the so-called consensus. What kind of reaction do you get from people around you because of your opinions?
Well, I have a lot of friends who think like I do about this, but then there are the detractors, of course. And it was 2007. 21 years after I left Greenpeace, when they removed my name as a co-founder of Greenpeace on their website, on their international website. And they did that because I came out in favor of nuclear energy publicly, in an effort to correct the one serious mistake I had made in my early years in the movement, confusing nuclear energy with nuclear weapons, or putting it in the same category. We should put nuclear energy in the same category as nuclear medicine. Nuclear medicine is a beneficial use of nuclear technology, and so is nuclear energy. And even as a scientist, a young man as a scientist, I fell into that trap. And so I decided to make up for my sins by joining the Clean and Safe Energy Coalition of the Nuclear Energy Institute of the United States as co-chair of an effort to change public opinion about the benefits of nuclear energy, and spent 6 years doing that. I don't think it's had as much of an effect as I hoped it would, as the anti-nuclear movement is still basically in charge of this policy in so much of the world, and it's such a big mistake. I mean, Denmark would be a perfect place for nuclear energy, because you can't have hydroelectric energy so much like Norway and Canada, because you don't have the topography, and because you're pretty flat. and it's only in countries with the right mountains and large rainfall which can have hydroelectric. As you know, Norway is 90% hydroelectric, Brazil is 80%, Canada is 60% hydroelectric. But you do have the ability to have nuclear energy in Denmark, uh, and it is applicable anywhere in the world. It doesn't depend on rainfall and topography. Even if you don't have water for cooling nuclear energy, it can be cooled with air. It's a bit more expensive to do that, but nuclear energy can be deployed anywhere in the world. And the fuel for it is for tens of thousands of years in the future. Because right now we are only using the uranium 235, which is only 0.7% of natural uranium, the rest being uranium 238, which can be made into a nuclear fuel in a nuclear reactor powered by uranium 235. And we are already doing that in France and Russia. But that is the future, is converting the uranium 238 and the thorium, which is much more abundant than even uranium, can be converted into uranium 233, which is not a natural element, but is fissile. In other words, can be used in a nuclear reactor to produce energy. So this one small amount of uranium 235 that exists in natural uranium can be used sort of like the biblical narrative of the loaves and fishes, where Christ took one fish and one loaf of bread and fed a multitude. And it's analogous to that. It is. I'm not a particularly religious person of any sort, but I do believe that that's an interesting analogy, that you can take this teeny amount of uranium 235, which exists naturally on the Earth, the only fissile isotope on the Earth, and take these two other substances, uranium 238, which occurs with uranium 235, and thorium, which is a separately mined mineral, which is at least 5 or 6 times as abundant as uranium. And you can multiply the amount of fissile material by tens of thousands of times in the final analysis. There, that's the future for you, nuclear energy.
But actually, it's the talk for nuclear energy in Denmark is kind of rising. People getting more and more aware of the possibilities it gives. But the politician is so they are so obsessed with this idea of 100% windmill energy. So they kind of like waving. They will not. Some is okay, find it positive, but the majority of politicians will not even consider it at this point. So it seems like something in the future.
Well, yes, Ricky, it is in the future, but it might not be very far in the future, because as I've said, at a certain point, this will be self-correcting when people realize this was the wrong path to take when their lights go out and they have no heat and they have no appliances and they are stuck in the dark and cold. The only reason that human beings were able to come out of Africa in the first place was because of fire, shelter, and clothing. And if you take the fire away in the form of the electricity away,
No.
you cannot live here.
Patrick Moore, final question. If I gave you the power to change the politics around the world, the worldwide politics, if we should not go for CO2, what would you change? What kind of changes would you make to the world policies?
Well, first I would say stop demonizing fossil fuels and burn them as clean as you can. That is what we should do, because we can burn them clean. We have the technology to do that now. So the other thing I would say is focus on nuclear energy, because we can replace half the fossil fuels we're using today with nuclear energy in the right technologies. All the buildings in the world, for example, could be run 100% with nuclear electricity and get rid of the use of fossil fuels in buildings. So the reason to do that is not because fossil fuels are bad. It's so we can stretch out the life of fossil fuels, which are finite, compared to nuclear, which is close to infinite from our time scale. So that would be the biggest thing I would do. Then I would also educate people into understanding that plastic is one of the most important and versatile materials we have. It's a big part of all our lives, and a very important one, and a very beneficial one. And also the concern for life and species. Become involved in true efforts to preserve species extinction, etc. Don't get involved in these fake stories. There are such things as species recovery programs, which are running all over the world to help species to recover from near extinction. And this is a good thing to be doing from an environmental point of view. And look at the full balance of things. Human beings are part of nature. We are not separate from nature. And look towards using science to our benefit for both the environment and human welfare, instead of thinking that these are opposites. Human welfare and the environment are not opposites. They can be one and the same. I guess those would be some points I would make. Thank you very much for having me on with you, Ricky, today.
What is the future? Do you have anything plans for the future? Anything coming up?
Well, my future hopefully will last a bit longer. I'm already 73 years old, but we live longer these days because of the fossil fuels and the good food and lifestyle understanding and understanding nutrition. So this is a good thing. And I wish everyone a long life. And I hope that we don't go into this spiral towards socialist, communist governments, because it will be bad for our children and our grandchildren. Thank you very much for having me on with you, Ricky, today.
Thank you for doing this. I appreciate it. Have a nice day.
You too, Ricky. Bye now.